Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing tough numericals. Up to question number 306 I have discussed. Now I will continue from the question number 307. These numericals are tough and are fit for IIT, JEE Advance and A.I.I.M.S. Some question may be asked in Neet also, but because questions are tough, hence these questions can be asked in IIT Advance and A.I.I.M.S. Okay, there is more possibilities. Now I will continue from the question number 307. N gram of a substance X reacts with m gram of substance Y to form p gram of substances R and q gram of substances S. This reaction can be represented as follows: X plus Y is equal to R plus S. The relation which can be established in the amounts of the reactants and the products will be: first option, N minus P, that is equal to P minus Q. Second option, N plus M, that is equal to P plus Q. Third, N is equal to M. And fourth, P is equal to Q. Again I am reading one more time. N gram, small n gram of a substance X, capital X, reacts with m gram of substance, small m gram of substance Y, capital Y, to form p gram of substance R, P small p, and substance R, capital R, and Q of substance S. This reaction can be represented as X plus Y, capital X plus capital Y is equal to capital R plus S. This is given in question. The relation which can be established in the amounts of the reactants and the products will be: first option, N minus M, that is equal to P minus Q. Second, N plus M, that is equal to P plus Q. Third option, N is equal to M. And fourth option, P is equal to Q. Just you have to solve it. Okay, it is a conceptual, and I think if you think in a proper way, you can solve it. Now just you think. After that I will give the hint. Now I am giving you hint. In question it is given X plus Y is equal to R plus S. And question is N gram of substance X. Substance X has N gram and substance Y has M gram. And products are given R plus S. Then R is Q. R is Q gram and S is R is P gram and Q is again I am telling you, N gram of substance X means X is N gram and Y is M gram, small m, both are small, and R is equal to means product, first product is P gram, and second product S, that is the Q gram. Correct? And this you can represent as X plus Y is equal to R plus S. Correct? Then now you have to tell a relation which can be established in the amounts of reactants and the products. Then now here X plus Y is equal to R plus S. Then X is N gram, Y is M gram, and first product R is P gram, second product S is Q gram. Then now N plus M means both are reactant. Both are reactant. N plus M, that is equal to P plus Q by law of conservation of mass. And quickly you can answer N plus M, that is equal to P plus Q by following the law of conservation of mass. As second option is correct. Actually it is full of concept. Okay. Second option is correct. N plus M is equal to P plus Q. Now next question I am reading. Hydrocarbon contains 86% carbon. 488 ml of the hydrocarbon weigh 1.68 gram at STP. Then the hydrocarbon is an first option alkane, second option alkene, third option alkyne, fourth option arene. Again I am reading one more time. A hydrocarbon contains 86% carbon. 488 ml of the hydrocarbon weigh 1.68 gram at STP. Then the hydrocarbon is an first option alkane, second option alkene, third option alkyne, fourth option arene. Correct? Question is just conceptual. Hydrocarbon contains 86% carbon. This is important. A hydrocarbon contains 86% carbon. 488 ml of the hydrocarbon weighs 1.68 gram at STP. Then the hydrocarbon is an first option alkane, second option alkene, third option alkyne, fourth option arene. Just to think it is full of concept. Just to think, at least fast to think, because you have to solve the numericals within 1 minute. Okay, this can be solved, this numerical can be solved, this question can be solved within 1 minute. Just to think. Now I am giving you hint. Percentage is given. Carbon is 86%. It is a hydrocarbon. It means hydrogen is 14. Carbon is 86%. It means hydrogen is 14. Total is 100. Because it is in percentage. Then carbon is 86%. Hydrogen is 14%. Atomic weight of carbon is 12 and hydrogen is 1. Then percentage atomic weight, that is how we will calculate. Then 86 divided by 12 and 14 divided by 1. Correct? This is based on empirical formula. Numerical says based on empirical formula. Then here carbon is 86%, hydrogen is 14%, atomic weight of carbon is 12 and hydrogen is 1. Hence percentage atomic weight is equal to what? 86 divided by 12, that is a 7.1. And hydrogen percentage atomic weight is 14 by divided by 1 means 14. Then now ratio you can convert in ratio. Then ratio will be 1:2. 7.1 is carbon and nitrogen is 14. Means 1:2. Correct? Ratio is 1:2. Then what is the actually empirical formula? Then empirical formula will be CH2. 1 carbon, 2 hydrogen. CH2 ratio is 1:2. And what will be the empirical formula? Empirical formula is CH2. And what is the empirical formula? Weight. Weight, empirical formula weight. Then you can add it. 12 plus 2, CH2. 12 plus 2, 14. Correct? Now in question it is given that 22,400 ml at STP weigh how much? In question it is given 488 ml of the hydrocarbon weighs 1.68 gram at STP. Correct? Then this is the starting point to calculate further. Then we know that according to the question 488 ml of the hydrocarbon weighs 1.68 gram at STP. Then for 22,400 ml means for 1 mole. Correct? Then this 488 ml hydrocarbon weighs 1.68 gram. Then for 1.68 divided by 448. Then for 22,400. Just to multiply it by 22,400. Then you will get 84. 84 means molecular weight is 84 because 22,400 ml at STP. Weight of the 22,400 ml STP is equal to 1 mole. 1 mole means molecular weight. Then now molecular weight you calculated 84. 1.68 divided by 448 into 22,400 upside. Then you will get 84. Then 84 is the molecular weight of the given hydrocarbon. Then now empirical formula weight you are knowing and molecular weight also you are knowing. Then what is the value of N? Then 84 divided by 14. 84 divided by 14, that is the value of N, means 6. 84 divided by 14 means 14 6 is 84. You will get 6. Then what will be the formula of hydrocarbon? Then C6H12 because N value is 6. Then empirical formula was CH2. Then now it became C6H12 means it is alkene. C6H12 it is following, that is the this double hydrogen is double of carbon. Correct? Then C6H12 that is the formula of alkene. Alkene double bond. Correct? Then now its correct option is alkene. Alkene, that is the second option is correct. It was very conceptual, and if you are knowing the, I can say, empirical formula, numericals, how to solve, only then you can solve it. Now next question 309 I am discussing. 100 ml of 0.1 N hypodechlorized iodine by the addition of X gram of crystalline copper sulfate to excess of Ki. The value of X is molecular weight of copper sulfate 5H2O is 250. It is given. Then first option is 5.0 gram, second option 1.25 gram, third option 2.5 gram, fourth option 4 gram. Again I am reading one more time. 100 ml of 0.1 N hypo dechlorized iodine by the addition of X gram of crystalline copper sulfate to excess of Ki. The value of X is first option 5 gram, second option 1.25 gram, third 2.5 gram, fourth 4 gram. Okay, here you have to understand the question. 100 ml of 0.1 N hypo dechlorized iodine by addition of X gram of crystalline copper sulfate to excess of Ki. Means X gram you have added copper sulfate, X gram you have added to the excess of Ki. Then iodine dechlorized. Correct? This you remember. This is the only things you have to understand. Then now, what is the value of X gram of crystalline copper sulfate? Crystalline copper sulfate molecular weight is given 250. Okay, option is there, X value 5.0 gram, second option 1.25 gram, third option 2.5 gram, fourth option 4 gram. Just to think in your mind how we will solve. Think fast. Keep in mind you have to solve the numericals within 1 minute. Okay. Just to think. After that I will give you hint. Now I am giving you hint. Here you have to write reaction between copper sulfate plus Ki, because copper sulfate was added in excess Ki. Then copper sulfate 5H2O plus 2 Ki. It will give K2SO4 plus Cu(I2) plus 5H2O. And this Cu(I2), 2Cu(I2), it will break into Cu2I2 plus I2. Correct? Again one more time reaction I am telling you. Reaction between copper sulfate and Ki, 2 Ki, balanced equation. CuSO4 5H2O plus 2 Ki. It will give K2SO4 plus Cu(I2) plus 5H2O. And after that in second step, Cu(I2), 2Cu(I2), it will give Cu2I2 plus I2. Then this I2 is going to be just dechlorized. Then because you have to cancel the Cu(I2), hence you have to multiply first reaction by 2. Then right side Cu(I2) and in second equation 2Cu(I2), both will be cancelled. Okay. Then what will be the remaining? Then remaining will be balanced equation 2CuSO4 5H2O plus 4 Ki, because you have multiplied whole reaction by 2, 4 Ki, and product side you will get 2K2SO4 plus Cu2I2 plus I2. This is the balanced reaction. Then now equivalent weight of copper sulfate 5H2O is given. Its molecular weight, that is the 2. Actually here both are same, equivalent weight and molecular weight both are same. Its value is given 250. Then now further you have to calculate 100 ml of 0.1 hypo, that is equivalent to 100 ml 0.5 N copper sulfate 5H2O. Correct? Here 100 ml 0.1 N hypo is equivalent to 100 ml 0.1 N copper sulfate 5H2O, because this has decolorized iodine completely. Question it is given 100 ml of 0.1 N hypo decolorized iodine by the addition of x gram of crystalline copper sulfate to excess of potassium iodide. It is given in question. Then 100 ml point N hypo is equivalent to 100 ml 0.1 N copper sulfate 5H2O. Then now you can calculate very easily. 1000 ml means 250 these things. In question it is given molecular mass 250. Then 1000 per liter equivalent means per liter you remember. Then 100 ml 0.1 N hypo is equivalent to 100 ml 0.1 N copper sulfate. Then whenever volume you are writing, you have to write the strength there only into strength, always make it habit. Then 1000 ml is equal to 250 into 0.1 M. 250 into 0.1 M. Okay, what is the 250? 250 is the equivalent weight or molecular weight. Then 1000 ml is actually present in 1000 ml contains 250 gram. But here it is actually 1000 ml should contain N, but here it is 250 gram 0.1. 250 gram 0.1 N. It is not complete N. 250 into 0.1, that is present in 1000 ml. You remember, 1000 ml contains 250 into 0.1 gram, means 25 gram. 25 gram copper sulfate 5H2O. Then for 100 ml, very simple way. 1000 ml contains 250 into 0.1 N gram copper sulfate. Correct? Then for 1 ml, how much? 250 into 0.1 divided by 1000. Then for 100 ml, in 100 ml how much? Just to multiply by 100, then you will get 250 into 0.1 divided by 1000. Then you will get 2.5 gram. Because 100 will be 100 and down 1000 is there. Then only 10 will be down remaining, because upside 100 down 1000. Then both 0 will be cancelled and only 10 will be remaining down, and 0.1 is upside. Then again it will become 1 by 10, then 100. Then 250 divided by 100 means 2.5 gram. Hence mass of copper sulfate in 100 ml will be 2.5 gram. Correct? That is correct option is third option C, 2.5 gram. Correct? 100 ml contains how much X? That is the 2.5 gram copper sulfate. Now next question I am telling you. Question number 310. The element whose an atom has mass of 1.086 into 10 to the power minus 26 kg. Correct? The element whose one atom has mass of 1.086 into 10 to the power minus 26 kg is first boron, second calcium, third silver, fourth zinc. Which element is there? That you have to tell. Again I am reading the question. The element whose an atom has a mass 1.086 into 10 to the power minus 26 kg is first option boron, second calcium, third silver, fourth zinc. Just to think. I think this is a theoretical question. I think you will be able to solve. It is not very, it is just conceptual. It is not very tough, but you have to think. Easily you will not get the answer. Just to think, at least to think. After that I will give you hint. Now I am giving you hint. Gram atomic mass of the element. Gram atomic mass, actually one atom mass is given. One atom. That is a 1.086 into 10 to the power minus 26 is given. Then one atom mass you are knowing. Then gram atomic mass you can calculate. Gram atomic mass by multiplying it with Avogadro number, because it is the mass of one atom, 1.086 into 10 to the power minus 26, one atom. Then for Avogadro number, how much? That will be the gram atomic mass of the element. Then multiply it with Avogadro number, means 6.0 into 10 to the power 23 kg. After multiplying, you will get 6.516 into 10 to the power minus 2 kg. Correct? Because 1.086 into 10 to the power minus 26 into 6.0 into 10 to the power 23. Then one is minus 26, other is 23. Then now after solving we will get 6.516 into 10 to the power minus 2 kg. Then in gram, you will get 65.16 gram. Correct? 6.516 into 10 to the power minus 2. Minus 2 is there. That means it is in a kg. Then in gram, it will be 65.16 gram. Hence, atomic mass will be 65.16 AMU. Then this is the atomic mass of 65.16 is the atomic mass of zinc. Hence option, fourth option is correct. See how indirectly it was given, you have calculated. One atom mass was given, then you multiplied by Avogadro number, then you got atomic mass. Then after solving you got 65. Then 65.16. Then that is the atomic mass of zinc. Hence correct option is zinc. A very good question. Okay. Now next question I am reading. The unit of joule per Pascal is equivalent to, it is a theoretical question. The unit joule per Pascal is equivalent to, first option, meter power 3, means cubic meter power 3. Second, centimeter power 3, means cubic centimeter. Third, centimeter cube, decimeter cube. Fourth, none of these. One more question I am discussing. The unit joule per Pascal is equivalent to, first option, cubic meter. Second option, cubic centimeter. Third, cubic decimeter. And fourth, none of these. Just to think, this is theoretical, but it is full of concept. You think, actually all theoretical things I have discussed. in the previous classes for 11th, 12th complete I have discussed. Okay. After that also I have discussed many formulas which was not common. Now applying all these things you can solve all numericals. And now just to think, the unit joule per Pascal is equivalent to first cubic meter, second cubic centimeter, third cubic decimeter, fourth none of these. Just to think. After that I will give you hint. Now I am giving you hint. Joule per Pascal means J divided by PA. Then joule is the unit of work and PA means Pascal is the unit of pressure, means work divided by pressure. Then what is the unit of work? This work is equal to N into M, Newton meter, Newton into meter, Nm, and pressure is Newton per meter square. Pressure unit is N, M power minus 2. That is the pressure unit. Newton into meter power minus 2. Newton per meter square. That is the pressure. And work is Newton into mass. Newton into mass. Means force into mass. Correct? And pressure I told you that Newton per meter square. Then here in the place of work you write N into M divided by for the pressure N into M power minus 2. Then you will get, after solving, N will cancel and M is upside and down is M power minus 2, hence you will get MQ, M3. Hence correct option is first option. First option meter cube, cubic meter. Now next question I am reading. From the following masses, means 312, question number 312. From the following masses, the one which is expressed to the nearest milligram is first option 16 gram, second option 16.4 gram, third option 16.428 gram, fourth option 16.4284 gram. Again I am reading question. From the following masses are given. From the following masses, the one which is expressed to the nearest milligram is first option 16 gram, second option 16.4 gram, third option 16.428 gram, fourth option 16.4284 gram. You have to tell that can be expressed in the nearest milligram. Just to think, this is the theoretical. You are able to solve these numericals. It is not theoretical, complete, not numerical, but you can solve it. Just to think. After that, I will give a hint. Now, I am giving you a hint. Actually, it is expressed to the nearest milligram. That is the 16.428, 3 digit. Milligram is what? 1000? 3 digit only, not the 4, not the 2. Hence correct will be the third option, 16.428. Can be expressed to the nearest milligram. 1000 milligram is equal to 1 gram. You know, that's why correct option is 16.428 gram. Correct? Now next question I am discussing. Mass of a mole of electron is mass of a mole of electron. First option 0.20 milligram, second 0.02 milligram, third 0.55 milligram, fourth 1.00 milligram. Again you listen. Mass of a mole. Mass of a mole of electron. A mole of electron. Remember, mass of a mole of electron is first option 0.20 milligram. Second option 0.02 milligram. Third option 0.55 milligram. Fourth option 1.00 milligram. It is also a very good question, conceptual, just to think. After that I will give explanation. Okay, just to think. Now I am explaining it. Mass of one electron, you know, mass of an electron, that is the 9.1 into 10 to the power minus 31 kg. You always remember mass of electron, proton, neutron. Always you keep in mind. Then this numerical is based on this. Numerical is tough due to this, because many students will not know what is the mass of electron. They might be not remembering. Those who will remember, they can solve it. Then mass of one electron, that is equal to 9.1 into 10 to the power minus 31 kg. Then mass of 1 mole of electron, just to multiply by Avogadro number. Correct? 1 electron mass is 9.1 into 10 to the power minus 31 kg. Then for Avogadro number, how much? Just simply multiply by 6.02 into 10 to the power 23. After multiplying, you will get 5.5 into 10 to the power minus 7 kg. 5.5 into 10 to the power minus 7 kg you will get. That you can express in milligram also. Kg you can convert in milligram, that is by multiplying it by 10 to the power 6. 1 kg means what? 10 to the power 6 milligram. Then just to multiply by 10 to the power 6. Then after solving, you will get 0.55 milligram, because 5.5 into 10 to the power minus 7 into 10 to the power 6. Then what will remain? Only 1 upon 10 will remain. 1 upon 10 will remain. Then 5.5 into 1 upon 10 means 0.55 milligram. Hence third option C is correct, 0.55 milligram. One more question I want to discuss. Okay, after that I will stop. Question number 314. The mass of nitrogen per gram hydrogen in the compound hydrogen is exactly 1.5 times the mass of nitrogen in the compound ammonia. The fact illustrates first the law of conservation of mass. Second, the multiple valency of nitrogen. Third, the law of multiple proportions. Fourth, the law of definite proportion. Again, I am reading one more time. The mass of nitrogen per gram hydrogen in the compound of hydrogen is exactly 1.5 times the mass of nitrogen in the compound ammonia. Again I am reading you, listen carefully. The mass of nitrogen per gram hydrogen, means nitrogen and hydrogen, that relation you understand. The mass of nitrogen per gram hydrogen in the compound hydrogen is exactly 1.5 times the mass of nitrogen in the compound ammonia. The fact illustrates first option, the law of conservation of mass. Second, the multiple valency of nitrogen. Third, the law of multiple proportion. Fourth, the law of definite proportion. I think this question, if you have studied, you can say theory, then you can solve it very easily. It is full of concept. Okay, just to think. After that, I will give the hint or I will explain it. Think it. Now I am giving the explanation. Ratio of masses of nitrogen per gram of hydrogen in the hydrogen and ammonia, just to compare, that 1.5 is to 1. 1.5 is to 1. Ratio of masses of nitrogen per gram of hydrogen in the hydrogen and NH3, that is equal to 1.5 is to 1. That you can tell in another way. 3, you can say 1.5 into is to 1, that is equal to 3/2 is to 1. 3/2 is to 1. That is the 3 is to 2. 3 is to 2. Correct? Which is a simple whole number ratio. This illustrates the law of multiple proportion. Correct? This both you consider. Ratio of masses of nitrogen per gram hydrogen. In both you have to compare hydrogen and NH3. Then in hydrogen, that is the in both you are considering in hydrogen and in NH3. Then in hydrogen, 1 is to half is to 1. That is equal to 3 is to 2 is to 1. 3/2 is to 1. Means 3 is to 2. 3 is to 2. Okay. If you will multiply by 2, then you will get 3 is to 2. 3 is to 2 in both. Then this is the this illustrates the law of multiple proportions. Today I am stopping only here. Next class again I will continue. Thank you.